Okay, now let's turn to the oligopoly market. An oligopoly market has a small number of large firms. So now one feature here is that because we have small number of large firms in the market, so now there's a strategic interactions in the market. Now your decisions affect my profit, and then my decisions affect your profit. Second feature of the market is product can be either homogeneous or differentiate. Third feature is entry is difficult. Entry is difficult, so which means that in the long run, there could be profit. All right, let's look at the example first, in order to see how the firms should decide its output and pricing decision. Okay, in the table here is a demand for water. This is a demand for water in townsware. So if you sell water at $120, nobody is going to buy the water. The profit you get is $0. Total revenue is $0. If you sell the water at $110, then consumers are willing to buy 10 liters, and the profit at the total revenue you can get is $1,100, and so on and so forth. Okay, suppose in this town there are two suppliers. One is Jill and Jack. To supply water, all they need to do is they just pump water after the wells. So the cost, let's say cost, suppose the cost is zero, or marginal cost is zero, and there's no fixed cost. So now the total revenue is just this profit. Okay, if this water market is perfectly competitive, because marginal cost of producing 1 liter of water is zero, so we should expect that the price should drop down to zero, such that MI equal to MC. So the quantity market supply in the town is 120 liters, and the price of water is $0 because the cost is zero. Okay. So if it is perfectly competitive. If it is monopoly, suppose there's only one supplier, then definitely the monopoly firms will choose the quantity to maximize its profit. And you should know that this total revenue is also the total profit because of cost is zero. And clearly we can see that this firm should supply 60 liters water and charge a price of $60 in order to maximize its profit. Okay, that's the monopoly outcome. 60, 300, $3,600 profit. Okay, now there are two suppliers. So this is an oligopoly market, Jill and Jack. So how should Jill and Jack decide how many water they should pump after the wells and at what price they should charge? Okay, let's suppose one way Jill and Jack can do is suppose say cooperate. Say Jill can talk with Jack. Say okay, let's cooperate and act like a monopoly, because we know that monopoly we can earn a profit of $3,600, and this is called collusion. So Geo and Jack conclusions. And note that this is illegal in Australia. It's illegal, but let's suppose they can do that to form a cartel. Okay, so fine, they can say, okay, let's produce 60 liters of water together and charge a price of $60. And now another thing they need to do is that they got to decide how many liters of water should Geo produce, how many should Jack produce. Okay, so they gotta split this 60 liters between them. Suppose let's say they sit down to negotiate, decide Geo to produce 30 liters and Jack to produce 30 liters, such that altogether they produce 60 liters to the market. Okay, let's wait for a moment to see, is this stable? Let's do this reasoning. Okay, suppose Geo will think this way. Okay, given Jack produce 30 liters, so is it good for me to produce more? Let's say 40 liters. Okay, if it is 40 liters, okay, then now in the market there's going to be 70 liters, so the price will be $50. Price is $50, and Geo produced 40 liters, so it's $2,000. And previously, according to Geo and Jack's agreements, both of them produced 30 liters and a profit of $1,800. So clearly now the profit of $2,000 is bigger than $1,800. So Geo is going to say, okay, given that Jack, you produce 30 liters, I'm going to produce 40 liters. And similarly, Jack is not stupid. Jack knows that Jack is going to same reasoning in the same way. And so Jack is going to increase its output, quantity output to 40 liters as well. So now the market output will be 40 liters. So the price, so now the market quantity is 80 liters. Price is equal to $40. Okay, now Geo and Jack is going to keep reasoning. So Geo is going to say, given Jack produced 40, should I increase output? Okay, so suppose say, okay, Geo say think whether she should increase output from 40 to 50. So now if this is the case, the market supply will be 90 liters. Price will be $30. So now the profit Geo can make is 50 multiplied by 30. 50 Geo produce 50 liters of water. The market price is 30, so it is $1,500. So now this is less than previously. The profit she can make. $1,600. So profit for $1,600. So previously when the market supply is 80 liters, price is $40. The profit for Jack is $1,600. Profit for Geo is $1,600 as well. So now it's less than $1,600. Similarly for Jack as well. So now output of Geo is 40 liter. Output of Jack is 40 liter. Seems to be the equilibrium. It's the equilibrium. And we call it Lash equilibrium. It's invented by John Lash. So it's a situation where the players has no incentive to deviate, or is the best response given the other player strategy. So now Geo produce 40 liters water, Jack produce 40 liters water. Is a large equivalent, because given that Jack produce 40 liters, Geo does not have incentive to deviate from 40 liters, and vice versa. So let's the pricing and the output decisions in this oligopoly market. And actually we have name for this. This is called Kuno competition. And you should see that from this example, you should see that this strategic interaction plays a very important role in the output and pricing decisions of the firms. And if we compare the market output of Geo and Jack with the perfect competitive and the monopoly, we can see that the output, the duopoly, this is a duopoly because there are only two firms. It's bigger than the monopoly output, but it's less than the perfectly competitive output. So in analyzing an oligopoly market, we need to deal with these strategic interactions. There's one tools that we can use to handle this, to analyze this strategic interaction, which is we call it game theory. Game theory. So now I'm going to briefly go through this. Game theory is a big field by itself. Game theory can be a subject. So we are going to just talk an introduction of this. So a game consists of player. For example, previously we have Geo and Jack. Strategy or actions. Strategy is choice of action. For example, previously is quantity output in our example, and outcome or payoff. So when play these games, then the players receives a payoff. in our previous example, it is the profit that Jill and Jack derive. That's the payoff. Okay. Let's look at an example, which we call prisoner's dilemma. So in this game, let's suppose John and Mike. There are two players, John and Max. They commit a crime. So they are caught by the police. So they have two actions they can do: confess and not confess. Both John and Mike confess and not confess. So if both of them confess, the police got sufficient evidence to charge them, so they're going to be sentenced. So let's John get 8 years. So I'm putting negative signs in front of 8 because of the fewer years of sentence, the better. If both of them not confess, they're going to get a light sentence, which is 1 year. If, say, John confess and Mike confess and John not confess, then there's still evidence to charge them. So, but now because Mike confess, so he's gonna get a lighter sentence. So he's gonna go for free. And for John, there's a heavier sentence, 20. Similarly, if John confess and Mike not confess, John is going to go free and Mike will get a heavier sentence, 20 years. Okay, so now this is the games. So we see that we have players, actions, and the associate payoff. Okay, let's analyze the outcome of these games. First, let's look at dominant strategy. It's the strategy that a player will use no matter how the opponents does. Okay, let's check whether John has a dominant strategy. To check for this, it's very mechanic. Just ask two questions. If Mike confess, what will John do? Okay, let's have a look. If Mike confess, then we are in this row. So now, if Mike confess, John is going to compare this payoff with this payoff. So if John confess, he's going to get an 8-year sentence. If he not confess, he's going to get a 20-year sentence. Definitely 8 years better. So John the answer is that John will confess. Second question is, if Mike not confess, what will John do? Okay, let's check. If Mike not confess, what will John do? John is going to decide between whether to confess or not confess by comparing this payoff with this payoff. So now, definitely, if he confessed, he's gonna get a 0-year sentence. If not confessed, he's gonna get 1 year sentence. So he's gonna confess. Confess. So now we see that we conclude that no matter what Mike does, John will always confess. So this is the dominant strategy. Similarly, and you need to check by yourself, we're going to find that no matter what John does, Mike will always confess. So confess is also Mike's dominant strategy. So we see that Mike will always confess, John will always confess. So this is the outcome. Confess, each of them get a sentence of 8 years. So this is, we call it dominant strategy equilibrium. And we should observe that there's a better outcome here that they cannot achieve. There's better outcome here, 1 year sentence, which is better than 8 year sentence. So there's a better outcome not achieved. And this is what we call it a prisoner's dilemma. Both John and Mike act out of their own interest, and they end up in the outcome that's not the best for them. Okay, this confess is also a large equilibrium. Note that a large equilibrium is the equilibrium where, given the other player's strategy, nobody has incentive to deviate. So to check for this, what you can do is you can ask again a simple question here. First, you can ask, given Mike confess, will John deviate from confess to not confess? Okay, to answer this question, given that Mike confess, will John deviate from confess to not confess? So again, John compared this payoff with this payoff. So John confess, the payoff is 8 year sentence. No confess is 20 sentence. So clearly it's no. Second question, given John confess, will Mike deviate from confess to not confess? Again, now we need to check for a payoff. So given that given that John confessed, will Mike deviate from confess to not confess? Now Mike is going to compare his payoff, this one with this one. So currently his payoff is 8-year sentence. If he deviates, his payoff is going to be 20 years sentence. So definitely he's worse off. So he will not deviate. So the answer is no. Therefore, we indeed see that given the other players, strategy, nobody has incentive to deviate. So is this confess and confess is indeed a large equilibrium. And in our lecture notes, we have more examples. So make sure you practice by yourself. To try to find a dominant strategy, try to find a large equilibrium.